When do you have to have the vocab done by? Which is? Friday? So, naming acids and bases. We have binary acids. And then the oxyacids. Binary acids.
That's like hydrochromate.
Right. Hydrogen and another. And I'm going to put non-metal. So only 2 elements. So you've like HBr is, oh actually I should put, we have a hydro prefix. And then we add the IC ending. So HBr would be
We cross out buffer solution on our vocab.
Yep.
Oh, what's the word? Buffer. I just looked at it. It was like a paragraph. Like I'm not writing that down. Oxygen. What is it?
KW.
KW is 1 times 10 to the negative 14.
Oxyacids have a hydrogen and a polyatomic ion. And if you have an ATE ending, what does that change to? IC. ITE ending changes to?
OUS.
Yes. 8 to IC, I to us. So if you have,
So what category would the hydrocyanic acid be?
I'm not for sure.
Under
Yeah. Would you use hydro? What is CLO?
It's like, yeah, hypochlorite.
What is I?
So that'd be hypochlorous acid.
Ide would be in a binary acid, so you change it to IC. So this would be hypochlorous acid. So you'll be able to use it at ion chart. What do bases have?
They have less hydrogen. No.
Hydroxides, right? And make sure when we're writing the formulas, if they give you the name and you write a formula, you still have to check the charges, cross the charges like you normally would. Questions on naming? We did another an example of a base. What's the formula for?
Water.
Copper hydroxide. Copper 2 hydroxide.
Cu2.
Mm-hmm. Yep.
What's the other copper? Copper 3.
1.
Copper 1. I didn't know that.
Copper oxide.
Copper what?
Only they have some still.
Would be CuO. There'd be no hydrogen.
Copper 1 times 10.
Copper 1 hydroxide, yes. Mm-hmm. To show that it's the +1, not +2 ion. Roman numeral 1.
Copper 2, you have to say copper 1.
You'd say copper 2 hydroxide and copper 1 hydroxide. That's the names of them. Okay, determining conjugate acid-base pairs. Let's say we have what is our acid?
H2SO4.
And how do you know that?
That's a strong acid. Use something that donates.
Yes, it donates.
It's donating a proton. Right. And so this makes water our base. It has accepted a proton when you look at what it product form. So which one's our conjugate acid?
Hydronium.
And our conjugate base is HSO4 minus. So the acid always is paired with the conjugate base. The base is paired with the conjugate acid. If you think about if you want to get back to the reactants, so if we go from the right to the left, H3O has to donate a proton. It has to act like an acid in order to get back to its reactant form. HSO4 minus would have to gain a proton in order to get back to H2SO4, so it's acting as a base if you go backwards. That's why that is the base, conjugate base. Okay. Next is calculating all those equations. So pH.
Leave those up there on the board.
No.
We use an note card.
You don't need a note card, do you?
Yeah. It's just not about this note card.
That's a lot harder than this.
It's not.
Not really at all. Not one bit.
On a scale of 1 to 10, that's like a 2 and 6 like a 12.
So you can find pH and pOH using our negative logs. If I want to know the hydroxide concentration,
I brought Chex Mix.
what would we do?
What was the question?
If I want to find hydronium concentration,
Well, you're going to have to take the negative, the pH to the 10th power.
yep, 1 times 10 to the negative.
That's what
Yeah, you did it backwards, didn't you? And then make sure your pH, if it's a decimal like 4.7, you have to actually put that in your calculator. Push equals. We want an integer as the exponent. And then the same with the hydroxide concentration.
Those things are going to change.
Why is it 1.7?
That's why I was so confused.
Right, they're the same, but you have to use pOH with the hydroxide concentration.
Keep those up there. Let's try to get down on no cards. I think that'd be fair.
Can we at least
I'll
have
think
the
about
answer
it.
issue?
Right, because of age.
Yeah, Mrs. Knee said if we were.
Okay.
If you were convincing.
We have how many tests this week? We test every day. Actually, we have 6.
All right, here's a good
That's how many equations we need to know.
Here's a
There's
good
a
one.
lot. Plus, you're giving us 2 tests on Friday.
Here's a good one.
No, me.
Or did it count, no matter how good we do on this test, we're still gonna fail the final and fail the second?
Yes.
You guys, you know what? I'm already failing. So I can get best grade all year on tests. That's your test.
Alright, yeah, obviously this isn't working.
I'll give you the equations on a piece of paper.
Yes!
Or just leave them up there.
I was gonna say.
And you don't have to waste trees.
Our persuasion wasn't working too well, so I was
What's pH plus POH equal?
14.
Yes. And the product of the two concentrations is
Times that I get 14.
That's on the board too.
Oh,
Do you want to do any examples of this?
And we got the equations. They're pretty good.
Okay.
Stop touching this one. Like, honestly, every second this is touching.
If I make this, we get a note.
We already have the equation. You're fighting a losing battle here.
Strengths of acids and bases. What are our strong acids?
HBr, that's what I know.
Go.
HBr. Oh, that H is horrible. 6.
H2SO4.
HI, H2O.
HBr.
HCl, HNO3, and HClO4.
Mm-hmm.
Is that chlorate?
Perchloric.
Hey, can you put that on the thing too?
And our strong bases?
First two.
Alkali and alkali earth. With an OH.
Magnesium.
Wait, so all hydroxides are?
Of those two groups are strong bases, yep.
What's that word I forgot the one.
And what does that mean? What does a strong acid mean?
It's a strong electrolyte.
And what does it do?
It burns through stuff faster.
No, it. Yeah.
Completely
Dissociates.
ionizes or dissociates, yes.
That's with the acid.
Yep.
Wait, so the strong ones are the ones you don't have to do that little X thing with?
Right. For the strong ones, you don't have to use X because you know how much dissociates. All of it dissociates.
That's why we like strong
Okay, so
acids.
that's like
Those ones get ran out
those
by
pictures
zero.
yesterday, the one that was most synchronized.
So strong. Mm-hmm.
Wait, so then the one with the two colors in it was weak? Like a much bigger
If the green and the white were still together, it was weak.
Wait, so we can cross out compounds and make buffer solutions?
Yep. Do you guys want to do a weak acid pH problem?
Yes. I was just going to ask you to do one of those.
Let's do the titration problem first, and then we'll go back and do that.
Actually, we do have titration first.
So let's use our two acids and bases, or our two.
That's a strong acid.
Yep, it is.
I thought we were doing a weak acid. Oh, we're doing a titration.
Titration.
So give me a volume of hydrochloric
I
acid.
think that'd be NaCl.
5 milliliters. Oh, whoops.
That'd be cool though. If you could just turn hydrochloric acid into water.
5 milliliters.
What molarity is it?
2.5.
But Jesus.
Strong. What volume of sodium hydroxide did it take to 11 milliliters? And we want to know the molarity.
Hey. Hey.
So, find the moles of hydrochloric acid. How do we do that?
13.
Right. Don't forget to change that to liters. 0.005.
Somebody get out of the truck. Alright, I got it. Is it point?
Munger's already got it.
125.
Munger beat you.
0.0125.
There you go.
That's right.
And for this reaction, it's a 1-to-1 ratio, but if it weren't a 1-to-1 ratio, you'd have different numbers. So I'm just going to write this in here.
No, that sounds like superficial or something.
And then how do I find the molarity?
And molarity is moles over volume.
And our volume would be
11.
No. 0.0.
in liters. Don't forget to change it to liters.
One.
1.14.
And that's the molarity
Of the base, yep.
Oh, that wasn't terrible. Thanks.
As long as the problem is just like that.
So,
As long as you give us
what is
hydrochloric
that first
acid and
equation?
NaOH, we'll be perfectly fine.
Mm, this one?
Yeah.
Yep,
That's that too.
yep.
Are you gonna have that equation?
Moles over liters. No, you know that one.
Okay, give us hydrobromic acid plus NaOH then.
It wouldn't be any different.
Hydrobromic acid plus potassium hydroxide?
Nope. Maybe it would give you the molarity of sodium hydroxide, and you'd have to figure out what the volume that it would need to neutralize it.
What do you mean 1-to-1 ratio? Is that the hydrochloric?
Right.
At the end, you just plug it
Like
in.
the two products?
To the two reactants. No, sit.
If you knew the thing was 1.14,
If this would have been H2S or something, if it's a diprotic, then you would have needed a 2 here, so then it would be 1 to 2. And so you wouldn't have the equal number of moles.
Are yours gonna be,
would you
like, are they gonna be balanced already?
You may have to balance it.
would you have to do ice if it was a diprotic acid? Or a
Yeah, you should always just check it.
They're unbalanced, so we have to realize it's like
If it's already written out, I would say it's probably balanced. But if it's in a word format where it just said hydrochloric acid neutralizes sodium hydroxide, then you'd have to write out the equation yourself.
would you have to ice if it was a weak acid?
Yeah.
Or is it
Well,
not in this?
we won't do weak acid titrations.
I can imagine you just
So,
carrying it
if you knew the molarity was 1.14, but you didn't know the milliliters, at the end you do 1.14 equals 0.015 x,
Yep.
and then you have to 0.015 divided by 1.015.
Yep. Okay, let's do a weak acid pH problem. So what's the pH of HF?
We always do HF. Let's do something else.
Something else. How
I
about,
don't know how to do something else besides HF.
You know how to do it all.
it's not going to change it.
Yeah, it's just the same thing except different letters.
I don't like that. That's so bad. So what is it?
So this is, if you need to find the pH of a weak acid solution, I know. What molarity do we have?
3.
3? Wow,
Dang.
That high?
that's high. We'll see what it comes out with. See if you picked a good number or not.
Would that be like, could that be negative?
Wait,
Maybe.
time out. Yeah.
That'll probably be a negative pH, but let's do it anyway.
Let's make it smaller because then, then it'll be under 5, which means we don't have to test it, right?
2.
Yeah, that too. I don't know if you picked a good number for that.
Just let's do
Okay.
it.
Let's do it.
3. Let's do 2. Little dot.
Should we add a dot?
Yeah.
No.
Add a dot.
Yeah.
Wow. Kill the adventure. Makes it 0.3.
I don't know if this is going to be good either. I don't know. We'll see. So what do we do? What's our change?
Minus x plus x.
Right, because we don't know how much dissociates since it's a weak acid. If it's a strong acid, we know x would be 0.3 if it was a strong acid. So our change is 0.3 minus x plus x. Right, we need to know the Ka value. Those will be given to you, whichever ones you need.
So you in. Okay, it's actually.
What's the name of this acid?
Nitrous.
Yes, nitrous.
Because I'm looking
What's the chemical formula for
4.5 times
nitrous
10
oxide?
to the negative 4.
That'd just be NO2.
What?
Nitrous oxide. Would that be NO2?
You can get high.
Something like that.
You put it in a car.
Speedboat is
So this is equal to x times x over 0.3.
No, just don't even write it right now because it doesn't matter.
Okay, it would be minus x. We're assuming x is very, very small compared to 0.3, so we can leave it out. So 4.5 times 10 to the negative 4th times 0.3, and take the square root, 0.01.
Yes. It's small enough, right?
And then you divide that number
Let's
by
do 116.
0.3.
Okay, so to check it, you need to divide by 0.3 times 100. 3.87. There we go. 3.7%.
I just switched the 0.3 for 0.3. Big change.
So that's our what?
So that's our percent. So that means we're under 5. We can use our assumption and leave that x out. So we can leave x as,
Our answer is 0.3, right?
no.
No, that's what our answer
So now if x is 0.0116, that means that is also equal to the H plus concentration. So how do we find pH? Negative is 1.93. That's a good number. You picked a good number.
Would have been better if it was interesting.
We only get 1.4.
Now, if we would have had a weak base here, like copper 1 hydroxide, we would have had hydroxide concentration here. So X would have been equal to the hydroxide concentration, and then you would calculate pH from that, just in case.
Yeah.
Thank you. AMP test.
That's the AMP test. I'm just gonna grab one on the way
You guys want to do any other type of problem?
This chapter.
Chemistry or Canadian or one of those.
Do you want to go through one where
You try to write on it, we'll face it back.
you titrated something and you maybe put extra too much of one in and then you find the pH of it?
What?
We should. Is that just another test?
Yeah, we should.
Wait, what?
I don't know, it's a possibility.
Oh, it's possible.
Wait,
So it
what?
should be on there 100%.
So let's
Can we
do,
put it with the string?
You didn't have that. Jesse, come on, Jesse.
I'm running out of room on this paper.
Are you gonna finish that?
give me 2 volumes.
Can't.
25 milliliters. And 13 milliliters.
15.
15.
Ah.
Ooh, 13.
I heard 13 first. What molarities?
Add with the knife.
Hey, what is
3.
this? What is this for?
3 molar and
0.2.
I'd 6 molar.
0.2.
That's
Oh,
awful.
this is gonna be bad. You're gonna have to have. Oh.
I think we have extra acid, don't we? So we need to figure out what the pH is if we've added these 2 solutions together. The moles should be equal to each other if they're equivalence point, right? So how many moles do we have here? 3 equals x over 0.025.
0.075.
Wait, I thought that was our moles, not volume.
That's volume and molarity.
I thought that we just used different things.
No, I think,
If we just use m equals moles over your volume,
yeah,
we are using. Why do you have to, there's an x.
that's x. Yeah, sorry.
I thought that was a b.
Volumes in liters, but then how many moles of or base do we have? 2 zeros?
Yeah.
So which one is reacted completely? So we have extra HCl. How much extra? Because they should be equal to each other if they're at their equivalence point.
The HCl, the moles of HCl.
Since it's 1 to 1, we have more HCl than NaOH, so we have extra. So subtract them. And how much is left over? Oh, 724. I heard wrong. So if we want to find the pH, HCl is a strong acid. So we have 0.0724. How many moles of hydrogen ions are we going to create then?
X amount.
Strong acid.
Oh, so you subtract it.
Uh-huh. All of it. This is moles, not molarity. How would we get it into molarity?
Take that divided by
The total volume. So we need to add these two together. 0.038. So you need to take it because you've added these two together, and now you have 0.0724 moles in that solution, and the volume of that solution is the two added together. So our concentration is
1.91.
then you can take the negative log, yep, of 1.91. Ooh, negative.
Negative pH.
Negative 0.28.
That's pretty neat, guys.
If we would have had more base, we would have subtracted them still, but we would have had base here. You would have found the hydroxide concentration and then found pH from the hydroxide concentration.
How strong of an acid is battery acid?
I don't know.
It's 3 on average.
3 is the test thing.